This is Stas once again reporting from Leipzig, this time from our brand new cafe called Nur Leipzig. And it's high time, even though I haven't showered in 4 days and I'm really tired, it's high time and the children are screaming around me. Nevertheless, it's high time for another great Max tutorial. And today we're not going to talk about anything specifically awesome. We're not going to talk about mapping colors to other colors, or we're not going to talk about geometry. Instead, we're going to talk about something something incessantly boring. We're going to talk about multiplication. Yes, that's right. You all know what multiplication is. You take a number and you multiply it by another number, and you get a result. I'm not going to get into set theory and how you can derive multiplication from it, but one thing you should definitely remember about it is that it's commutative. So while 2 times 5 equals 10, 5 times 2 also amazingly enough equals 10. And we can generalize that by writing a times b equals b times a. Alright, you think, okay, so I remember all of this from school. This is not precisely rocket science, so you know, what am I gonna talk about here? Well, you see, Matt in the workshop said already that multiplication in jitter is not commutative. And what the hell does this mean? Well, don't worry, the multiplication itself is still commutative. So if you multiply a number by a different number, and if you turn around the order in which you multiply them, you still are going to get the same result. However, multiplication operators in jitter don't behave that way. And the reason for that is that they treat matrices received in different inlets as if they had different data types. Allow me to explain. First of all, let's create 2 jit.op matrices and give them a name. Call them matrix 1, or actually let's call them something more interesting. Call them bus, and make it a one plane char matrix with just one dimension and a cell number of 8. So what it will look like is, I'm going to show you in a second. Alright, so this is our first jit.op matrix, and we're going to make a second jit.op matrix because we're going to multiply both matrices together. So, and this matrix is going to get a different name. It's going to be called car. Alright, cool. So now we have to fill all 8 cells of these matrices respectively with values, because right now all the values are set to 0. So what we use for that is a new object called jit.fill. Jit.fill uses the name of a matrix to refer to it. It receives a list in its only inlet, good old max list, you all know what that is, and it uses that list to fill the cells of that matrix beginning from the left top cell. In this case, we only have a one-dimensional matrix, so we're going to go from left to right. So make a jit.fill, call it bus. Also make a jit.fill called car. Since it refers to a matrix by a name, you don't need to connect jit.fill to jit.matrix technically, and also you can see by the color of the patch cord that it doesn't send a matrix, it just sends a bang, in fact. It sends a bang when it's done filling the matrix, and we're gonna, now you're interested, huh? We're gonna just connect this bang outlet to the jit.matrix in order to output that matrix out the leftmost outlet of jit.matrix. God, I hope this makes sense. Alright, cool. So now we have to send lists to jit.fill bus, and I'm gonna make it in a really stupid and non-elaborate way. I'm gonna just multiply 4, 8, make a message box, connect it to jit.fill, duplicate that message box, and change the values slightly so we can see whatever's output as a result. Make it 2, connect it up to jit.fill, and make a jit.cell block to see what's going on inside our jit.matrices. Make 2 jit.cell blocks, connect them up, and now hit the message boxes. In fact, let's actually make a button so it's more convenient. Make a button and a toggle bang bang. No, not a toggle bang bang bang, just a toggle. No, not a toggle. Trigger bang bang. Guys, I'm not on top of, you know, Alright, hit that button and let's see what's going on in jit.cellblock. Alright, amazing. We have filled the 8-cell matrices with the values we wanted to fill them with. Now we want to multiply both matrices, which can make sense a lot, and if you have followed through the last tutorial, you probably already remember from when we were feedbacking that we were using jit.op. That we were using jit.op. Yeah. That we were using jit.op with an operator attribute of multiply to multiply two matrices. So, okay, cool. Let's wait for Max to... Yeah, okay, now it's there. Cool. Alright, delete the jit.cellblock objects and connect the matrices up to the respective inlets of jit.op. And now you would think that what comes out of those matrices is 16, 16, 16, 16, 16, 16, 16, right? So, well, no, that's not how it works. Let's make a jit.cellblock to watch what happens when what actually happens. Alright, make it a little bit wider so everyone can see. Connect up the jit.op and hit the button. And now what we see is a bunch of 0. Why the hell does that happen? Well, you see, jit.op, when it receives a char-typed matrix in its leftmost inlet, automatically begins to interpret whatever it receives into its rightmost inlet as a float. And if you send it a floating point matrix, it will interpret it, you know, as God intended it to be interpreted, as a float matrix. If you send it a char matrix, it will still be interpreted as a float, with 255 equaling 1 and 0 equaling 0. So you have 256 steps in between 0 and 1. And the reason why that happens is, you know what, don't ask me, because it really doesn't make sense. I guess it makes sense in a practical way, because you wouldn't come into the situation all too often when working with char matrices, which represent video usually, to multiply the numbers and get a bunch of you know, very high values as a result. Instead, you usually want to darken or brighten up the image, so char gets interpreted as float. Alright, so make a jit.cellblock and let's see if we can change the situation, because of course we can multiply values in the good old school math way that we have learned, and we do that by changing the type of the first jit.matrix that sends into the left inlet of jit.op to long. Long stands for long integer, and it's essentially a char, except it can go much, much higher. And my friend Sebastian is making fun of my Max MSP tutorial persona, and the kids are increasingly happy. Alright, okay, bang the matrix, and lo and behold, what we get is the good old expected result, 16, 16, 16, 16, 16, 16. So this concludes our little tutorial on multiplication and jitter. As you can see, Matt was right in saying that multiplication doesn't necessarily function in a commutative way, but also Matt was wrong, because multiplication is still multiplication. It's just that the char data type, when sent into the right inlet of the jit.op object with the op attribute of multiply, gets interpreted as a float if the matrix sent into the left inlet is also a char matrix. That's the whole gist here. This is good to know knowledge. I'll see you in the next tutorial, where I promise we're going to be making video again and making funny sounds, and I've got some ideas already. But until then, I have to come back to Berlin first, and I really need a shower. So bye guys, I hope you have enjoyed that.